Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lessons 7.1 and 7.2 guided notes on angles. This is our introductory lesson on angles, some symbols, the different types of angles that exist, as well as angles that exist when we have parallel lines cut by another line, which we call a transversal. So lots of different things in this lesson. Some things will be new to you. There will be some things you've probably seen before. There's a lot of terminology and symbols, though, that you're going to need to be familiar with. So let's begin with a vocabulary review of things that you're probably kind of familiar with already. An acute angle is an angle whose measure is less than 90 degrees. We'll use that term every now and then throughout this lesson and in our later lessons this unit, especially when we talk about triangles. An obtuse angle is an angle whose measure is greater than 90 degrees. A right angle is an angle whose measure is equal to 90 degrees, and we'll show you some symbols related to that as well. And a straight angle is an angle whose measure is equal or exactly 180 degrees. We'll talk about that when we deal with supplementary angles. We also have angles whose measures are greater than 180 degrees. They're called reflex angles, something we might have talked about in elementary school at some point, but we won't deal with here. The vertex is the point where two rays meet to create an angle or to create a corner of a triangle, for example, but the vertex is where two rays will meet. Now, we see some symbols here. This M, and it kind of looks like a little L here, and then a 1, means measure of angle 1. The M represents measure of. The symbol, I'm going to highlight it right here. Let me go ahead and highlight it. This symbol right here that kind of looks like an L is not an L, it's the angle symbol. So measure of angle 1. You're going to see that symbol a lot. I've had students at the very end of the unit say, what is that L? That's the angle symbol. You've got to be familiar with it. We've seen this symbol, I think, before. It's a squiggle with an equal sign underneath it. That means is congruent to or having the same measure. It's basically equals for angle measures or measurements. All right, one of the first things we're going to do is name an angle, and we can name an angle by its vertex and by its points. So this angle that's shown down below can be named in 4 different ways. One way to name this is angle 1. That's what the number that's inside the angle where we would have the measurement. We can also call this thing just angle B by the vertex, which is where the two rays meet. Again, rays are just one-sided lines, essentially. It starts with a point and then extends forever in one direction. We could also name this angle ABC with B, the vertex, in the middle, or we could switch around the order and name it angle CBA. Again, that vertex needs to be in the middle. So you could see all of these different ways to name just one angle. So I want you to kind of be familiar with that. So if I say angle 1, what I mean by angle 1 here is this yellow highlighted angle that I'm going to highlight here. It means this angle right here, and it really means the measure of this entire angle in here. So we could measure those. You probably did that in elementary school with protractors, but it's the measure of that angle. All right, let's talk about some line and angle relationships. Now, you don't have to copy anything down here, but I do want you to look at this. I want you to look at the symbols, and you're going to need to know these different types of angles. So the first one actually isn't an angle, it's parallel lines. Those are lines that never intersect. You've seen those before. We often name lines with just a letter. This symbol that I'm going to highlight right here in yellow, the 2 double lines going down, represents parallel to. So this says that line A is parallel to line B. We named these 2 lines, these are perpendicular lines with the letters M and N. This symbol that I highlighted in yellow right here, it looks like a little box or a square, that represents a right angle, and perpendicular lines are lines that intersect at a right angle. The symbol we use is an upside down T to represent right angles. So this means that M is perpendicular to N. Those 2 lines meet at a 90-degree angle. So you've seen those before. You may not have seen the symbols, but you've definitely seen those terms before. We also have vertical angles. This is one that is probably new for you. Vertical angles are created when we have 2 lines that intersect. So they're actually the angles that are across from each other, and vertical angles happen to be congruent. So angles 1 and 3 are vertical angles, angles 2 and 4 are vertical angles. Angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. That's going to be really important for us as we go into our examples here in this video. Adjacent angles, adjacent means next to. So adjacent angles are angles that share a common ray. In this example, that ray is BD that they share. So they have that angle 1 and angle 2, they have that ray BD in common. So they're right next to each other. They have to share a common ray though, they can't be separated. Now the two that students tend to mix up the most are complementary angles and supplementary angles, and you need to know these. So complementary angles are angles whose sum is 90 degrees, so they add up to 90 degrees. They could be adjacent, but they don't have to be adjacent. They could just be two angles that add up to 90 degrees. Supplementary angles are angles whose sum is 180 degrees. The way I remember complementary versus supplementary is I think about the alphabet. We've got C and S, C for complementary, S for supplementary. C comes before S in the alphabet, and 90 comes before 180. If you know that they are related to 90 and 180, then you know that 90 comes before 180 and C comes before S. So complementary is 90, supplementary is 180. Basically, a lot of the angle relationships we're going to see in this unit, we're either going to have angles that add up to 90 degrees, we have angles that add up to 180 degrees, or we have angles that are equal to each other in general. All right, let's go ahead and flip to the page and let's see some of our simplest examples, beginning with number 1. So number 1 says to find the value of x in each figure. If we look at these two angles, we know that they form a straight angle or straight line. These two angles are supplementary angles. Now you don't actually have to write that out normally, but I'm going to explain these examples using the terminology so it helps us remember it. So they're supplementary angles, which means they add to 180. So if I want to find x, all I have to do is take 180 minus 150. That gets me 30 degrees. So x is 30 degrees. In number 2, we have that square that represents a right angle, meaning these two angles are complementary angles. They add to 90 degrees. So to find the missing angle measure, just take 90 minus 40, and that's going to get us 50. Moving ahead to number 3. Remember, at any point, if you need to pause the video to copy anything down, please feel free to do that. So looking at number 3, it kind of looks like number 1, where we have a straight angle or a straight line, which means 180 degrees. So these two angles are supplementary angles. Take 180 minus 135. That will get us 45 degrees for that missing angle measure. Now, please pay particular attention to number 4. Every year I give it graded classwork on this, and the problem number 4 here, you have a similar one to this on your graded classwork, and every year I have students who are like, I don't know how to do this. So take a look at this. We're trying to find x. There's two ways to really find this. First of all, we have two lines that intersect, and that looks pretty darn similar to the vertical angles we saw on that first page of our guided notes. So what I know is that vertical angles are equal. So x and the 55 degrees are going to be equal. The other way I could find this that I didn't do was I've got a straight line. Let me go ahead and outline it here. This is a straight line right here, and we've got the 125 and the x that have to add to 180 degrees. So you could also take 180 minus 125 to get this angle measure. But either way, it's going to be 55 degrees. The easiest way is just to recognize that this angle right here and this angle here are vertical angles and need to be congruent or equal. Let's take a look at number 5. So we have another straight line going on here. So this is a straight line or straight angle. So those two angles, that the one we have and our unknown, are supplementary angles. Take 180 minus 120, you get 60 degrees. Number 6, we've got that square that represents a right angle. That means complementary angles. Take 90 minus 55. That missing angle measure is 35. All right, so we have to make things a little bit more algebraic. This is essentially a pre-algebra course. So in number 7, we have a more complicated example. And again, you're going to have a problem like this on your graded classwork and on your test. So I really want to make sure we take some time with this here because it is algebraic in nature and it involves solving equations again. One of those units we did when we were completely virtual, at least this year, if you're listening to this in a future year beyond the pandemic, hopefully. It may not have been something that you learned completely virtual, but looking at this, what I know about these two angles is that they are vertical angles. So we've got those two intersecting lines. So these two angles are vertical angles, which means they're congruent to each other. So what I can do is I can set 7x plus 19 equal to 68. And you'll see this is huge because I'm trying to make sure students in the classroom can see this because I know it's kind of tough to see in the room. We solve this by using inverse operations. It's a two-step equation. So just a reminder, we subtract 19 from both sides. That's the inverse of adding 19. That will get us 7x equals 49. The inverse of multiplying by 7 is to divide by 7. And so we find that x equals 7. All right, so let's go ahead and move on to some independent practice for you to try. So I want you to pause the video and give these 4 questions a try, including number 4 here that is a little bit more challenging. When you're ready, unpause the video and we'll take a look at these solutions. All right, so let's take a look at number 1. Hopefully you were able to find this solution. It's a pretty straightforward question. These are supplementary angles which add to 180. 180 minus 71 is 109. In number 2, we've got some complementary angles, so take 90 minus 9 to get 81 degrees. Number 3, we have some vertical angles here. So the easiest way to do this is to recognize that these two blue highlighted angles are vertical angles and have to be congruent. So x and 85 degrees are congruent, which means that x is 85 degrees. You could also take 180 minus 95 to get x as well. Number 4, we also have vertical angles, so we're going to set these equal to each other. So our equation we can use, and again, pretty much throughout this entire lesson and this entire unit, either the angles are going to add to 180, they're going to add to 90, or they're going to be equal, and in this case, they are equal. So we have 13x plus 20 equals 72. The inverse of adding by 20 is to subtract 20, so let's go ahead and subtract 20 from both sides. That gets us 13x equals 52. My final step is to divide both sides by 13. 52 divided by 13 is 4. All right, let's go ahead and take a look at some more complicated angles and their measures as well. Hello. So in our special types of angles, these are angles that you can go get your computer to do work too. Sometimes we get special angles that are formed when parallel lines are intersected by another line. We call that line a transversal. So anytime parallel lines are intersected by another line, we call that line a transversal. So let's talk about interior angles. Interior means inside. If you're an interior designer, you're decorating the inside of a home. Interior angles lie inside or between the parallel lines. So I'm going to highlight those, and I'll have to kind of keep erasing this as we go. These are the angles that are between the parallel lines. So those will be angles 3, 4, 5, and 6. Those will be our interior angles. Exterior angles are angles that lie outside the parallel lines. Exterior means outside. So that's going to be these green highlighted angles here. They're outside the parallel lines. So it'll be 1, 2, 7, and 8. Make sure you're using the angle symbol too. We want to get used to using that symbol. So angle 1, angle 2, angle 7, angle 8. You can just separate them with a comma. I just listed them in that box. Now things are going to get a little bit more complicated here. Now we have alternate interior angles. Alternate means like on opposite sides. Interior means between. So alternate interior angles are on opposite sides of the transversal. That's the alternate. And between the parallel lines, but they're also not adjacent. These pairs of angles are equal to each other. So there are 2 pairs of alternate interior angles. 3 and 5, they're on opposite sides of the transversal. They're between the parallel lines, but they're also not adjacent to each other. And you can kind of tell they look to be equal to each other. So angles 3 and 5, our other pair of alternate interior angles will be 4 and 6. They're on opposite sides of the transversal, between the parallel lines, but also not right next to each other. So we list them as pairs. So angle 3 and angle 5, and angle 4 and angle 6. We also have alternate exterior angles. When we talk about alternate exterior angles, those are on opposite sides of the transversal as well, hence the name alternate. Exterior means they're outside the parallel lines, but they're also not adjacent, meaning they share that common ray. So one pair will be angle 2 and angle 8, opposite sides of the transversal. They're kind of like diagonal from each other. and they're outside the parallel lines and again not adjacent. So angle 1 and angle 7 is our other pair. So we have them listed here. Angle 1 and angle 7, angle 2 and angle 8. The last type of angle, and again, you're going to need to be familiar with these. You're going to have to be able to identify them, and we're also going to need to be able to use this to find some missing angle measures, which we'll see in questions 8 through 15. Let's talk a little bit about corresponding angles. Corresponding means matching up. They're in the same position on the parallel lines in relation to the transversal. These pairs of angles are also equal to each other. These relationships will help you find missing angle measures. So let's identify these. So 1 and 5 are both in the top left-hand corner of their grouping of angles. So they're corresponding. 2 and 6 are in the top right-hand corner, so they're corresponding. 3 and 7, bottom right-hand corner, they're corresponding. And finally, 4 and 8, bottom left-hand corner. So when we list these, we've got angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and then angle 4 and angle 8. Now know that in other pictures, these numbers might be in a different order. The picture might not look exactly the same. So you really have to have an understanding of these because it's not always going to be angle 1 and angle 5. They might be different angle measures if we mix up those numbers. So let's go ahead down to numbers 8 through 15. So in numbers 8 through 11, it says in the figure at the right, C is parallel to D. We can see that here. And P is a transversal. That's a line that intersects those parallel lines. We know that the measure of angle 5 is 110 degrees. So I'm actually going to write that or slide that over next to that angle measure. So 5 is 110 degrees. Find the measure of each angle. So I usually don't even look at these problems over here. I just go right in and start identifying all of the angles in the picture and then go from there. So since angle 5 is 110 degrees, angle 2 is also 110 degrees. I know this because they're vertical angles. Now, from here, I generally find angles 1 and 6, which I also know are equal. I find those angles by taking 180 minus 110 to get 70 because I've got a straight line right here. I'm going to go ahead and highlight this in yellow. This is a straight line or straight angle. So angles 1 and 2 have to add to 180 degrees. And since angle 1 is 70 degrees, angle 6 is also 70 degrees. You're going to see a lot of repeats here. Now this is where sometimes students get a little stumped. They're like, I don't know where to go from here. Here's the deal. Angle 2 is like in the top right-hand corner of this grouping of angles right here. So is angle 4. That means they're congruent to each other. They're corresponding angles. So these guys are both going to be 110. Also, angle 4 and angle 5 are alternate exterior angles with each other. I know it looks kind of weird because it's sideways, but they're also going to be congruent to each other. From there, once you have one angle in this other grouping, it should be pretty easy. That means angle 7 is also 110, and I know I really have to try to squeeze that in there. And angles 3 and 8 are each going to be 70 degrees. So it's going to be kind of hard to identify these. It would help if they were a little smaller, but I want to make sure they're visible for students. So again, you see a lot of the same angle measures being repeated anytime you have parallel lines intersected just by one transversal. You'll see some questions where there's two transversals, and then that gets a little bit more complicated. So let's fill in these angle measures here. So angle 6 is down here, that's 70 degrees. Angle 8 is over here, that's also 70 degrees. Angle 2 is right here, that's 110. We found that one right away. And then angle 4 was over here. That was the one that was corresponding with angle 2, is also 110 degrees. And again, you just need to look at those angles that match up. Another thing that you'll notice is, let me just slide this down, is that in between your parallel lines, the ones that are on the same side also will happen to be supplementary. So angles 6 and 7 will add to 180, angles 2 and 3 will add to 180. So you'll see a lot of different relationships. Something else students notice is like these 4 angles going around, 3, 4, 7, and 8 have to add to 360 degrees. So you're going to notice a lot of different relationships with these angles. Let's try another one of these. In the figure at the right, G is parallel to K, and R is our transversal. If the measure of angle 7 is 60 degrees, so I'm going to slide that in here, find the measure of each angle. So again, I usually don't go right into the problems and start trying to figure out what angle 4 is. I fill in the picture first and then fill in the angles. Since 7 is 60, 8 is also 60. They're vertical angles. To find 5 and 6, take 180 minus 60, which is 120 degrees. And then again, we just need to figure out one of these from up above. So I would use corresponding angles. 8 is in the top right-hand corner, so is 4. So they're both 60 degrees. Once you have that guy, that means angle 3 is 60 degrees, and angles 1 and 2 are going to be 120. So when we go to fill in these angle measures, let's start with angle 4. That's up here, top right-hand corner, that's 60. Angle 6 is right down here, that's 120 degrees. Angle 5 is right here, that's 120. And then angle 3 is right here, that's 60. All right, so using this same picture, it asks us to identify a pair of vertical angles. So I'm going to only list one pair here, but there's lots of pairs of vertical angles here. So I'm actually going to pull these numbers out of the picture so it looks a little less complicated, because I think it looks kind of complicated. So let me just move these out of the way. So vertical angles are going to be in the same grouping, so they're going to both be up here or both be down here. So the angles that I picked were 3 and 4. They're vertical angles. But you could also choose 1 and 2, 5 and 6, 7 and 8. So you have a lot of different options there. Number 17, name a pair of corresponding angles. So I chose angles 1 and 5, which are both in the top left-hand corner. But you could also choose 4 and 8, top right-hand corner, 2 and 6, bottom right corner, 3 and 7, bottom left corner. Name a pair of alternate interior angles. We only have 2 pairs of these, so that will be 2 and 5 is what I had listed. I'll go ahead and highlight these. The other pair would be 3 and 8. Again, alternate interior, opposite sides of the transversal, between the parallel lines, but also not adjacent. Name a pair of alternate exterior angles. I chose 4 and 7, so I'll highlight those. Whoops, let me choose a different color. So these 2. You could also choose 1 and 6. So you've got to be familiar with these terms. It's going to take some time to get used to it. So, the more practice we get in class, the easier it's going to get.
So we're going to move ahead to our next section in the guided notes where we just look a little bit more at angles and parallel lines. So we're given that H is parallel to K. So line H and line K are parallel to each other, and T is a transversal that intersects those parallel lines. And we're given the measure of angle 1 is 110 degrees. Now I apologize about the angles getting a little messed up down here, but we know that angle 1 is 110 degrees. So I'm actually going to type that in here. So we've got 110 degrees for the measure of angle 1. It's always good to jot that in the picture if possible so we can use that information moving forward. All right, so once we have that information, number 20 says angle 1 and angle 2 are a pair of blank angles. So as I look at angles 1 and 2, I'm going to recognize that those are corresponding angles. They're in the same position along the parallel line with respect to the transversal. So they're corresponding angles. And again, we can notice that if I would take this group of angles here and I would copy and paste them on top of these, then angle 1 and angle 2 would be in the same position. Therefore, they are corresponding. And we know that corresponding angles are equal, so that means that the measure of angle 2 is also 110 degrees. So I'm going to go ahead and fill in this blank. The other thing I'm going to do is copy and paste this, and not copy and paste all of that. Copy and paste the angle, and we will put angle 2 down here. It's always good to fill in the picture as we go. So then it says angle 2 and angle 3 are a pair of blank angles. This is going to help us practice identifying different types of angles and finding those missing angle measures. Angles 2 and 3 are vertical angles. They're in that same grouping, but they're diagonal or across from each other. We also know that vertical angles are equal. So since angles 2 and 3 are vertical angles, I know that angle 3 is also going to be 110 degrees. Now, we also have a relationship between angles 1 and 3 because those are related to each other. We've got 2 blanks here. Those are alternate exterior angles. We know they're outside the parallel line, so that's exterior angles, and they're on opposite sides of the transversal. We also know that alternate exterior angles are equal, which means that the measure of angle 3 is also 110 degrees. Now, angles 2 and 4 are right next to each other. They're adjacent angles, and they're on a straight line, which means that they are supplementary angles. And we know that supplementary angles add to 180 degrees. So if I want to find the measure of angle 4, I need to take 180 and subtract off 110, and that will get me 70 degrees for the measure of angle 4. So the measure of angle 4 is 70 degrees. And I will take that and I will copy and paste it, or at least attempt to, down here for number 26. Our last question here, number 27, angles 3 and 4 are also going to be a pair of supplementary angles. They should add to 180 degrees. And since I've labeled my angles in my picture, I can see that angles 3 and 4 are supplementary. They do indeed add to 180 degrees, since 110 plus 70 is 180 degrees. All right, let's move ahead to our next set of questions. Again, just looking at these angle relationships. So we're given that line C is parallel to line D. P and Q are transversal, so we actually have 2 transversals here. And we are also given that the measure of angle 1 is 37 degrees. So we'll go ahead and put that in the picture. I think that's really helpful for us to do. So the measure of angle 1 is 37 degrees. Now, it says the measure of angle 4 equals blank. So we need to try to figure out what the measure of angle 4 is. Any ideas what this one is? Let's think about this. If we look at our picture, what's given, we have a 37 degree angle here. We also see a right angle up here, which is going to help us figure this out. So as I look at this picture, since this angle that's right here, I'm going to go ahead and highlight it in yellow. This angle is a 90 degree angle. It means that the angle next to it is also going to be a 90 degree or right angle. So I'm going to put a little box over there. So this angle right here is also going to be a right angle for us. And I know that it corresponds with angle 4. They're in the same position along the parallel lines C and D. So since these two correspond, I'll highlight those in green for us. I know that they are going to be equal to each other. So angle 4 will be 90 degrees, and that is because it is a right angle. We never want to assume something's a right angle. We want to use the information that's given to us in the picture. Since we are given that the right angle that's highlighted in yellow, we know that the one next to it has to be 90 degrees as well. And since it corresponds with angle 4, we know that it's also going to be a 90 degree angle. Now, angles 1 and angle 2 are going to be complementary angles. Let's talk about why. Remember, complementary means they add to 90 degrees. I know that they're complementary angles since angle 4 is 90 degrees. In fact, I'll copy that down here. Then I also know that angles 1 and 2 have to total 90 degrees. And when angles total 90 degrees, that means they're complementary angles. So if I want to find the measure of angle 2, since I know that angle 1 is 37 degrees, I need to take 90 minus 37. And 90 minus 37 is going to get us 53 degrees. So the measure of angle 2 is 53 degrees. And I'll fill that into the picture as well. It's really like putting a puzzle together. All right. So again, what we notice is angles 1 and 2 together are going to total 90 degrees. Since the right angle given up here is going to be the same as the right angle right next to it that's highlighted in green, which means angle 4 is a right angle of 90 degrees, which also means that angles 1 and 2 need to total 90 degrees. What we also notice is that angles 1, 2, and 4 total 180 degrees because they're on a straight line. Now let's look at the relationship between angles 1 and 3. Now we do have this extra transversal here, line Q, that's intersecting, but if we look along the transversal P and the parallel lines C and D, Angle 1 and angle 3 are going to be corresponding angles. It's a lot harder to identify these once we have two transversals for sure. They're corresponding angles, and when angles are corresponding, it means that they're going to have the same measure. So that means that angle 3 will be 37 degrees. Go ahead and fill that into the picture as well. Now, angles 2 and 5 are in that same grouping of angles, and they're across from each other. In fact, it might help to highlight some of the lines. So angle 2 is formed by these yellow highlighted lines. They also form angle 5, which means that those will be equal to each other, and also we call those vertical angles. And we know that vertical angles are equal, so it means that angle 5 will be 53 degrees. Go ahead and fill that in. Measure of angle 5 is 53 degrees. Now, something else that we can check from this picture is if the measure of angle 5 is 53 degrees, we've got a triangle here, and if you know about triangles, the total of the degree measures for the angles in a triangle will be 180 degrees. That's something we're going to talk about in our next lesson, but something we can preview. The total number of degrees inside of a triangle is 180 degrees. So since I know that my green and yellow highlighted angles are each 90 degrees, so are the angles below them, which means this would also be a 90-degree angle right here. I'm going to put a little highlight in blue. So that would be 90 degrees. And if I do 90 plus 53 plus 37, I do indeed get a total of 180 degrees. So I know also that angles 5 and 3 are probably correct based on the way that I labeled them. In this picture, we've got a lot of different relationships, a lot of different ways that you can go about finding the missing angle measures. This is just one of the ways to go about that thought process. As we continue with these guided notes, one of the things you'll notice is that the problem numbers don't match the questions. For example, problem number 35 in your guided notes in the video is going to be labeled as question number 20. I added a whole section into the guided notes, which is why those questions don't exactly match up, but all of the work and the rest of the portions of the problem do match up. So just ignore those problem numbers and make sure you're copying down the work for each of those questions moving forward. My apologies that I haven't re-recorded the entire video, but I did re-record it with the additions to the guided notes. I just didn't change it with the new problem numbers.
It says in the following figures, find the value of x, then find each of the missing angle measures. That last set of directions is really important. Students tend to forget about it. So in number 20, we need to recognize what's true about these two angles. They're on a straight line, which means a straight angle or 180 degrees. They're supplementary. They add to 180 degrees. So what I know is the relationship, again, is either going to be that the angles are equal, they add to 180, or they add to 90. So the equation I can write to represent this is just 3x plus x, which I wrote as 1x equals 180. This gets us a lot more practice with solving equations. That gets us 4x equals 180 degrees. 3x plus 1x is 4x. Solve that using inverse operations. We divide both sides by 4. 180 divided by 4 is 45. So we know x is 45. We need to find each of the missing angle measures. We have two angles there, x and 3x. So 3x is going to be 3 times 45, which is 135 degrees. So this angle right here is 135 degrees. You can write it right on the picture if you want. I just put it down below where I had a little bit more space. Usually on quizzes in this unit and on the test, I put a blank that'll say 3x equals so that you can find that angle measure. And then x we already know is 45. So we already found that. Let's take a look at number 21. Again, identifying what's true about these angles. You see that square, which means 90 degrees, they add to 90 degrees, they're complementary angles. So what I would do is write 7x plus 5 plus 22 equals 90, and those can go in any order. Let's combine our like terms. That we have two constants we can combine together, that's 22 and 5. So this simplifies to 7x plus 27 equals 90. Now let's just use those inverse operations. So the inverse of adding by 27 is to subtract by 27. That's going to get us 7x equals 63. Sorry, let me move that up a bit. Divide both sides by 7. we will determine that x equals 9. But again, we have to find our two missing angle measures. Our two angles, we already know, well, we know 22 degrees, so I guess we don't really have to do too much there, but we do need to find the 7x plus 5. So replace x, substitute 9 in for x, replace x with 9, do 7 times 9 plus 5 is 63 plus 5, or 68 degrees. Now, you probably would have already recognized that in some ways, just because you could do 90 minus 22 to figure out that angle measure. So something I see sometimes students will do is they will just automatically write like 7x plus 5 equals 68, and then solve that equation. That also works. So there's other ways to do this besides writing the equation in the exact same way that I have it, but I'm going to do it the more traditional or standard way. All right, let's take a look at a few more of these. So number 22. Again, we want to identify what's true about these two angles. These are vertical angles. Again, anytime you have two lines that intersect, you're looking at vertical angles more than likely. So they're equal to each other. So just set 3x equal to 105. That's a one-step equation. That's easy. Divide both sides by 3. We get that x equals 35. To find the missing angle measure, well, it should be 105 degrees, but you could do 3x equals 105. By taking 3 times 35. I actually didn't show that. I don't know why I didn't, but I'll type it in. So you could do 3 times 35. I'll use the x for multiplication. That's 105 degrees. Make that into a degree symbol for us. Yeah, it's one of those that, again, you might not need to show the work, but if you take 3x, 3 times 35 is 105 degrees. It's almost a silly example, but it's good to look at that relationship between the angle measures. And number 23, again, what's true about these two angles? Well, we know they add to 180 degrees. We've got a straight angle or straight line. So what I would do is write that 2x plus 72 equals 180. We'll subtract 72 from both sides to get 2x equals 108. Divide both sides by 2. X will be 54. And again, throughout this, you might need to pause the video. I'm not going to work through this as slowly as we would in class because you have the opportunity to pause the video here. Now, the one angle measure, we know it's 72 degrees. To find the other angle measure, take 2 times 54. That's 108 degrees. You have already seen that actually up above within your work. So you might even notice what that angle measure is without having to show all of that work. All right, we've got one more on this page, number 24. The two angles shown are supplementary, which means they add to 180 degrees. Find the value of x. So what I'm going to do, since I know that they add to 180 degrees, is I'm going to write 10x minus 1. Notice how I added the opposite and wrote 10x minus 1 as 10x plus negative 1. I'm going to highlight that because that's so important. Plus the 71 has to equal 180 degrees. Now, let's combine our like terms. Our like terms are the negative 1 and the 71. Negative 1 plus 71 is 70. So we get 10x plus 70 equals 180. Subtract 70 from both sides to get 10x equals 110. Divide both sides by 10. You will get that x equals 11. It doesn't tell you to do anything else, so we'll just stop there. X is 11. All right, we'll skip ahead to numbers 25 and 26 here next. Trying to see, oh, I do have some problems for you to try. Go ahead and pause the video, give these two questions a try. When you're ready, start the video and we'll look at your solutions. Don't forget to also find the missing angle measures after you find the value of x. All right, hopefully you did pretty well with these. Let's go ahead and take a look at number 1. We know that these angles are supplementary angles, which means they add to 180 degrees. So we can write 7x plus 5x equals 180. 7x plus 5x is going to get us 12x equals 180. Divide both sides by 12. We get x equals 15. Now, we need to find the two missing angle measures. We have 7x and 5x. So take 7 times 15, which is 105. 5x, which is 5 times 15, that's 75. You can double check to make sure they add to 180 degrees by adding them together, and they will. Number 2, so for this one, we can write 3x plus 8x plus 2 equals 90 degrees. Combine your like terms, 3x and 8x together to get 11x. So we have 11x plus 2 equals 90. Subtract 2 from both sides, that gets us 11x equals 88. Divide both sides by 11, you will get x equals 8. Now the other thing that you want to do here is figure out the missing angle measures, 3x and 8x plus 2. So for 3x, take 3 times 8, that's 24 degrees. For the 8x plus 2, replace x with 8, so do 8 times 8 plus 2, which is 66 degrees. All right, so our last page here, let's take a look at numbers 25 and 26. Use the figure below to answer the following questions. So I added this a few years ago based on some questions that are on your test. So it says to name a pair of vertical angles. We've got several. I'm going to list one of them. 1 and 4 is going to be a pair of vertical angles. If you're struggling with figuring out in this complicated, I don't know, this figure right here, which ones are vertical angles, you can trace the lines. Like if I'm looking at this line right here and this line right here, the angles that are formed are 1 and 4. If I'm looking at this line here and this line here, I'm looking at angles 2 and 5, so 2 and 5 are also vertical angles. The easiest one to choose would probably be 6 and 8 since they're over here by themselves, so that would also work. So you've got 2 and 5, 1 and 4, or 6 and 8. You also have 3 and the right angle here, but there's no name for that angle. So we're just naming these again with the numbers that are inside the angles. Name a pair of complementary angles. We need to remember that complementary means that the angles add to 90 degrees. So we're looking for 2 angles that add to 90 degrees. So I would say the easiest way to go about this is looking back at this picture over here. I know that we have a right angle right here, which means that angle 3 is also a right angle, but that doesn't give me 2 angles that add up to 90 degrees. But I also know that, let's see if I can draw this in, this entire angle here has to add up to 90 degrees, and that's 2 and 4 combined. So angles 2 and 4 would be vertical angles, and then these 2 angles combined need to add to 90 degrees as well. So 1 and 5 would be complementary. So the easiest ways to go about this, you could get more complicated, but we need 2 angles. When we say a pair, we mean 2. So not just an angle that equals 90, but 2 angles whose sum is 90 degrees. So 2 and 4 would work, 1 and 5 would also work. Again, we could get more complicated by pairing up different angles, but we're not going to go crazy with this. Like technically, you could say angles 1 and 2 would also be not complementary. They would add to 90 degrees, but I wouldn't go too crazy. If you overthink it too much, it's easy to make a mistake. All right, I know the problem numbers skip to numbers 39 through 42. It seems like I haven't fixed that yet. Let's look at number 39, which is technically number 27, but so be it. Number 39, it says angles Q and R are complementary. Remember, the word complementary means that those angles add to 90 degrees. So find the measure of angle R if the measure of angle Q is 24 degrees. It's basically the same as questions, I'm going to go all the way back to numbers 1 through 6, essentially, except we don't have a picture given to us. So we know that the angles are complementary, which means they add to 90 degrees. All we need to do is do 90 minus 24 to get 66 degrees. Now, you really could draw a picture for this. So we could say, hey, we've got this pair of complementary angles. We know that angle Q is 24 degrees. I'm just making this really simple. So maybe this is angle Q. It's 24 degrees. We need to find the measure of angle R. I'm just going to put an R in here, which we wouldn't normally do. But if I know that these 2 angles have to add to 90 degrees, because this is a right angle and we know they're complementary, take 90 minus 24 to get this angle measure. In number 40, angles J and K are supplementary. Find the measure of angle J if the measure of angle K is 29 degrees. Remember that the word supplementary means the angles add to 180 degrees. So you can simply do 180 minus 29 to get 151 degrees. Again, a way you could do this is you could make a straight line like this for a straight angle. Change my arrows there. There we go. And I'm going to give a 29 degree angle. So we could let this guy be 29 degrees. That's going to be measure of angle K. And then we can let this guy right here be J. Well, if I know they have to add to 180, take 180 minus 29 to get 151 degrees. You really need to know the terminology here, though, in this unit. All right, number 41, we've got angles G and H are complementary. If the measure of angle G is 48 degrees, the measure of angle H is 2x degrees, what is the value of x? We have to remember that the word complementary means they add to 90 degrees. So I would write 2x plus 48 equals 90. That's a two-step equation. Let's use those inverse operations. We're going to subtract 48 from both sides to get 2x equals 42. Divide both sides by 2. That's going to get us that x equals 21. So again, just using those, whoops, sorry about that, guys. Just using those inverse operations, we determine that x equals 21. Again, you could draw a picture here if we know that they're complementary. I really should put the box in here to represent this. We know, let's say, G is 48 degrees. And then we know this guy up here is 2x. We know they have to add to 90, so 2x plus 48 equals 90. All right, last one of these before we see the last three. Angles J and K are supplementary. If the measure of angle J equals 64 degrees and measure of angle K equals 4x degrees, what is the value of x? We need to recognize that supplementary means they add to 180 degrees. So we'll do 4x plus 64 equals 180. Inverse operations means we subtract 64 from both sides. To get 4x equals 116, divide both sides by 4, we get that x equals 29. Again, you could draw a picture to represent something like this. We've got our straight angle for the 180 degrees. Whoops. Bear with me. There we go. We know one of our angles is 64 degrees, so that's going to look something like this. Again, just approximating it. I'm not making it perfect. My pictures will not always be drawn to scale. If this guy is 4x, we know that 4x plus 64 has to equal 180. So you could always draw a picture to help you, but it doesn't matter. You still need to know the terminology. Complementary is 90, supplementary is 180. All right, so last picture, I threw this one in there a few years ago, also because you have a question like this on your test. So it says, using the figure below, answer the following questions. Well, this one's pretty nasty because you have parallel lines being intersected by two transversals, forming a triangle in the middle. So we're showing you something that you're actually going to see in the next lesson as well. But let's start by filling in this picture. I wouldn't try to find angles 1, 2, and 3 right away. What I would do is fill in this picture. So first off, I know that this angle is 49, so that means this angle in here is also 49 degrees. You have a triangle smack dab in the middle of this picture. If you know, which you'll know after the next lesson for sure, that the three angles in a triangle have to add to 180 degrees, the way you could figure out the measure of angle 1 is to do 65 plus 49, which is going to get us, let's see, we've got 6 plus 4, or 5 plus 4 is, 5 plus 9, goodness, is 14. Leave a 4, carry a 1. That's going to get us 114 degrees. And then take 180 minus 114 degrees. So that's going to get us 66 degrees for that missing angle measure. I'm going to make that a degree symbol. So angle 1 has to be 66 degrees. Again, just takes a little bit of finagling there, but this guy's going to be 66 degrees, and I can fill that in over here. So again, add the two that were given, 65 and 49, they add to 114. Subtract from 180, measure of angle 1 is 66 degrees. Now, from here, things get to be a little bit more complicated. If you can imagine taking this transversal out, which I can't actually physically do, but I've got this angle in green right here that's 65 degrees. And this angle up here is going to correspond with this. It's kind of in the top right-hand corner of these groups of angles. But again, if I could imagine taking this transversal out, it wouldn't, that's this one right here, it wouldn't impact either of these angles in any sort of way. So this angle and this angle are corresponding, which means that this angle up here is also 65 degrees. And so the measure of angle 3 is 65 degrees. Although I would argue the measure of angle 2 is pretty easy to find from here, since we have a straight angle right here. So this is a straight angle going on right here. So this angle, the 65 degrees, and measure of angle 2, we have to be careful because this is a 2, not 2 degrees. Sometimes students get confused between angle measures and the angle names. These two angles that are highlighted in blue have to add to 180. if you take 180 minus 65, you get 115 degrees for this guy right here. So the measure of angle 2 is 115 degrees. This is something we're definitely going to see more of. We're going to be going over these angle names over and over and over again, so it should get a little easier to memorize or know these angles. But just start practicing these words and using the vocabulary as you're thinking through some of these questions. All right, thanks for listening.